Hi everyone. This week in Level F, we will be going over lessons 129 through 132. You will need worksheets 110 through 113. The math journal, math balance, the 4-in-1 ruler, the meter stick, the Casio calculator, the math card games book, and the basic number, multiplication, fraction, and corner cards. In lesson 129, we will solve for unknowns on the math balance. Ask the oral warm-up questions. Notice that there is a third option for the last question. You could put a weight on the 1 peg and the 3 peg. I really like this lesson so much because it has the students diving into algebra in such a concrete way.
Okay, so for mystery problem 2, it says put weights at the 3, 4, and 10 on the right side of the math balance. And on the left side, put a weight at the 2 peg and 3 weights behind the 5 peg. So you'll notice that you can't really see how many weights there are if you're looking straight on at the balance. So do this, I don't know, have your child turn around or do it when your student is working on something else so that it's not obvious how many weights are on the 5. Of course, you've already done this with a mystery problem number 1, but since we're not covering that, I just wanted to cover those bases with you. So then you can ask your student to tell you what the equation should be. And as your student is saying the equation, you could be writing it down. So they should come up with something like this. 5x, x is the unknown, plus 2 equals 3 plus 4 plus 10. Now your student may have gone ahead and said 5x plus 2 equals 17. If that's the case, that's fine. It's true. But for this exercise, we wanted them to have the numbers added up in a line, not the total. Because we're going to show them how you and I learned to subtract 2 from one side and subtract 2 from the other side so that we can get 5x by itself. But before we show them that on paper, we're going to actually do it on the math balance. So I will ask my student, how can we remove the weight on the 2 and still stay in balance? So if I'm going to remove this weight, what do I need to do over here? Well, I could subtract 2 from the 3 and get 1. That would still keep us in balance. So we can actually write that equation. 5x equals 1 plus 4 plus 10. Now we can add up the 1, 4, and 10 and get 15 on the right side and 5x on the left. So x has to be 3. And sure enough, we can show them that there are 3 weights hanging on the 5. Okay, so after that demonstration, go ahead and move on to the worksheet. I would do problem number 1 together. So this is what the equation is going to look like. And I would go ahead and have them say, well, 5 times 3 is 15. Here's 9 plus 2x. What can I do with the 9? If I take the 9 off of the balance, what would that leave me over here? Because I have to remove 9 from both sides. We just determined that in the last demonstration. So 15 minus 9 would be 6. And here we have the 2x. And so x obviously has to be 3. This might be clearer without the light on.
Then go ahead and have your student complete the worksheet and notice that there might be a slight difference in how they write the equation from how the book does. But as long as it's correct, it's fine that it's a little bit different. Ask the in conclusion questions and play negative corners or top and bottom corners, which are either S10 or S11 in the Math Card Games book. There is a blog about S11 on the Right Start Math website, and I'll leave a link to that in the description. In lesson 130, we have a review and game day. So after asking the oral questions, have your student complete and correct the review. Then they can play fractions in 4 operations, which is game F45 in the Math Card Games book. Here are the lessons that you can review if you feel the need to. All right, if your child missed either question 1 or 2 in the oral section, have them review lesson 114. For problem number 3, go ahead and review lesson 108. For the write the answers questions, review lesson 93 for question number 1, lesson 97 for question number 2, and lesson 109 for question number 3. For the do the calculations problem, review lesson 111. For the section where it says connect these points in order, review lesson 126. For the problem where they ask the child to find x, go ahead and review lesson 129. And for solving the word problem at the bottom, the square problem, go ahead and review lesson 110. In lesson 131, we will be converting units using conversion factors. There is a correction, so if your book was printed before April 18th of 2018, please follow the link in the description. The warm-up questions are on worksheet 112. This lesson and the next several lessons are teaching dimensional analysis. It's also known as the factor label method. You may remember this from high school chemistry. You may get some kickback from your student for several reasons. Firstly, this seems like a complicated way to figure out a problem that your student can do mentally. And I had to keep reminding my son that yes, for these simple problems, you can figure them out in your head, but for more complicated ones, you will be happy to know this method. So you might want to use something like that on your students as well. Secondly, this is a new and brain stretching type of exercise. So pleasantly persevere with your child and you might get thanks when your child gets into high school. I think that the first 2 problems are on the worksheet are pretty clear, but let's take a look at the conversion factors section and the converting units section.
Okay, so starting off talking about conversion factors, we're just going to do something simple and say 4 equals 4. Do you agree with that statement? Obviously, your student will say yes. So then we can write 4 divided by 4 equals 1. Is that a true statement? Yes, it is. So now we're going to move on to something like this. There are 100 centimeters in 1 meter. So 100 centimeters equals 1 meter. That can also be written as a fraction. 100 centimeters, 1 meter, divided by 1 meter. And that equals 1. We could also write that as 1 meter over 100 centimeters equals 1. Both of these are correct. And these are called conversion factors. So that explanation should help your student with problem number 3. But let's look now at the converting units. So what they say is let's find out how many days are in 10 weeks. So we're moving from weeks to days. We know the weeks, we want to find the days. The conversion factor that has weeks in the denominator and days in the numerator would be this: 7 days in 1 week. So we're going to say 10 weeks, because that's how many weeks we have, times 7 days in 1 week. We can cancel out these labels. Remember, it's also called the factor label method, and we just get 10 times 7 equals 70 days. Now, this is what I'm talking about. Most of your students will say, I can simply multiply 10 times 7 and know I have 70 days. And that is so true, and I'm glad they can do it. but they want to learn this method because it will come in handy later on, and you might as well get it now rather than suffering through in high school.
So go ahead and finish up this lesson with the in conclusion questions and play Lowest in the Corners, which is game P18 in the Math Card Games book. There is a video about this game at the Right Start Math website. I will leave a link in the description. Please read the comments section first, however, so that you can catch the mistake in the video, and then that'll make it easier to understand. In lesson 132, we continue converting units. Ask the oral warm-up questions and have your child complete problem number 1. Then let's take a look at how you can use the dimensional analysis method to solve a multi-conversion problem.
Okay, so let's look at the second page of the lesson. It says 2-step problems. Sometimes it's necessary to make more than one conversion for a problem. So we're going to move from yards to inches, but we need to get to feet first. So how can we do that? Well, 1 yard equals 1 yard times how many feet? There are 3 feet in 1 yard. Now we can cross out these labels, yard, and see that there's 1 times 3, so there's 3 feet. Now we need to move from feet to inches. So how many inches are in a foot? There are 12 inches. We can cross out feet, and we simply multiply 3 times 12 to get 36 inches. So 1 yard equals 36 inches. Now let's look at problem number 3, letter C. Marn wants to buy 108 inches of fabric. It is sold at $8 a yard. What is the cost? So we're moving from inches, that's how many inches Marn wants, and we know that there's 108 of them, to feet, to yard, to the cost. So this is a pretty complicated one. So we start off with 108 inches, and that equals 108 inches times 1 foot is in 12 inches. So here we're going to be able to cancel those inches. Then we're going to move to yards. There's 1 yard for every 3 feet. So we'll cancel those inches, we'll cancel those feet, times there's $8. The cost is $8 per 1 yard. So now we get to cancel the yard. So we could say, okay, 12 times 3 is 36. 108 divided by 36 equals 3, and 3 times 8 equals 24. So my answer is $24. Now, some of your students, and this goes for all of the problems, but I'm just mentioning it now, might be confused as to why we have 108 inches equals 108 inches. Well, first of all, that's true. But second of all, it's because we're going from inches all the way down here to the cost, and we're doing all of this work in between. Remember, we're moving from what we know, the inches, to what we want to know, the dollars. If we didn't want to know the cost, we could have stopped at yards. How many yards do we need?
Go ahead and ask the in conclusion question and then play multiple solitaire, which is P19 in the Math Card Games book. And that's all for this week. Thanks so much for joining me. I'll see you next time. Bye-bye.